So I got a request to do some more related rates problems, so let's try another common one. So in this case, we have gravel that falls off of a conveyor belt at a rate of 20 cubic feet per minute. Now the diameter of this conical shape which is formed from the gravel falling off the conveyor belt, the diameter is consistently 3 times the height of the cone. Now, we're trying to figure out how fast the height of the pile is growing when the pile is 9 feet high. So what I'm going to do is list all of the variables and relationships we're given at the start here. So we have that the height is going to be 9 feet, and we also have that the diameter is always going to be 3 times the height of the cone. Now, just intuitively, we can also see that this radius is going to be half of the diameter. So it's going to be the diameter over 2. This allows us to create a relationship between these two variables later if we need to. Now, I'm also going to write all the rates we're given in the problem. We're given that the gravel is falling off at a rate of 20 cubic feet per minute, and that is a volume over a time. So we have the change in volume over change in time is 20 cubic feet per minute. We don't have the change in height over change in time, but that's okay because that's what we're trying to calculate. So now that we have all these variables, we need to find an equation that will relate everything. And I think that the volume of a cone should do just the trick. But notice if I take the derivative here, I'll end up with a dr over dt. I don't want to have that because I don't have any dr over dt rates listed here. So instead what I'm going to do is relate these two variables right here. So I have these two equations or these two relationships, and what I can do is take this diameter and plug it in for d in my radius equation. That will give me this relationship right here, which I can plug in for this r up here. So now that I have this, I can take it and plug it in for r. 3/2 times height, and we have this whole value squared since r was squared, and then we just need to simplify this whole expression. Now if I simplify this, I should get 3 pi over 4 times the height cubed. So now that I have this equation, notice now if I take the derivative of both sides, I'll end up with dv over dt and dh over dt, which are exactly the two rates that I need. So I'll go ahead and take the derivative of both sides. And if you use the power rule on h cubed, you should get 3h squared, but then you'll need to use the chain rule, which will give you the dh over dt. So if you simplify everything and take the derivative here, you should end up with this equation in total. Now we can take all the variables we have and plug it into this equation. Now from here, it's just going to be algebra to get this dh over dt on one side of the equation. Now these right here are all the algebraic steps listed out to get this rate by itself, and assuming that I did not make any algebraic errors throughout this problem, you should get 80 over 729 pi feet per minute as your final answer to this problem. So that is how fast the height of the pile is growing when the pile is 9 feet high.